Hello students, last time we have seen the binomial expansion using the Pascal's triangle, and in that I had already told you the Pascal's triangle can be used up till say power 6 or 7. When the powers are too high, it becomes difficult to make the coefficients from Pascal's triangle. Now, here today we are going to see a more general formula which can be applied for even higher powers. So certain terms we should know here. So first one is factorial notation. Now what is factorial notation? Factorial notation is shown by this sign n factorial, and n factorial will mean starting from n, making 1 less, the product of all the factors up till 1. What does this actually represent? Now take for example, I have 3 students and I want to make them sit in a row on 3 chairs. How many ways I can do this? Suppose these are 3 chairs. So in how many ways I can do this? So the first chair can be filled by any one of the 3 students in 3 ways. Now same student cannot sit on the second chair. So second chair can be filled by 2 ways, and similarly the last chair can be filled by 1 way. So total number of ways will be 3 into 2 into 1, and that is nothing but 3 factorial, which is equal to 6. Okay, now n factorial, I can write it as n into, now see, n minus 1 into n minus 2 up till 1, that will be n minus 1 factorial. And this I can repeatedly apply. So n into n minus 1 into n minus 2 factorial and so on. Now take for example, I want to simplify 5 factorial upon 3 factorial. So using this property, I can write 5 factorial as 5 into 4 into 3 factorial divided by 3 factorial. So 3 factorial will get cancelled, and that is equal to 20. Okay, so then we have to study something called as combinations. Combinations. Now combinations are nothing but selections. Suppose, say I have 5 students and I want to select 3 out of them to make a team or some game or program. So in how many ways I can do these teams? How many teams I can make? And that is given by the combination 5C3. This is this bracket. It's called as the combination. So 5C3, and on your calculator the combinations are ready for you. You have to first press, if it is Casio, the scientific calculator, press 5, then you press shift, and after that press division sign. After shift, press division sign, and then press 3, put 3, and then equal to sign. So in this case, you will get 5C3 as 10. So that is the meaning of the combinations. So in general, NCR is n factorial upon r factorial into n minus r factorial. But you don't have to worry about this formula. We'll be doing this on the calculator. Now, you have to know some of the properties of these combinations. So first of all, NC0 and NCN, both of them are equal to 1, and NC1 will be equal to n. Also, NCR is same as NC n minus r. Now take for example 5C2, and that will be same as 5C 5 minus 2, that is 3, and the value of both of them will be equal to 10. Okay, now why do we have to study this combination for binomial expansion? So let us see the relationship between combinations NCR and binomial expansion coefficients. So consider the expansion of a plus b the whole square. Now by using the Pascal's triangle, what are the coefficients in a plus b the whole square expansion? 1, 2, 1. And these coefficients in the combination notation, I can write it as 2C0, 2 I can write it as 2C1, and again 1 I can write it as 2C2. Then take the next expansion, a plus b the whole cube. So by Pascal's triangle, the coefficients will be 1, 3, 3, 1, which in terms of the combinations, 3C0, then 3 I can write it as 3C1. Now 3C1 will be same as 3C2. And finally the last one I can write it as 3C3. Then a plus b to power 4, the coefficients are 1, 4, 6, 4, 1, which in terms of combination I can write it as 4C0, 4C1, that is 4, 4C2, that is 6, then again 4 I can write it as 4C3, and finally 1 I can write it as 4C4. So take the expansion of a plus b to power 4. So in this, the first coefficient will be 4C0. In the first term, a will have the full power, a to power 4. Then the next coefficient will be 4c1. I will reduce a's power by 1. So I will make it a cube. Introduce b here. Then next 4c2. Reduce a's power by still 1. Increase b's power by 1, b square. See that total power should be 4. Then the next coefficient is 4c3. Reduce a's power by still 1. Increase b's power by 1. And finally 4c4. And in this term, p will have the full power 4. So, similarly, if I want to write the expansion of a plus b to power 5, tell me what it will be. Yes, first coefficient 5c0, a to power 5. Then next coefficient 5c1, a's power reduced by 1. Introduce b here. Then 5c2, a's power still reduced by 1. B's power increased by 1. Then 5c3, a's power still reduced by 1. B cube. Then 5c4, a, b to power 4. And finally 5c5. In this term, a's power will become 0. So b will have the full power 5. So if we continue like this, I can write a general expansion of a plus b to power n, and that will be nc0 a to power n, then nc1 a to power n minus 1 b. In the next term, the coefficient will be nc2, a's power still 1 less, n minus 2, b square, and like that continuing. The last term will be ncn, a's power will become 0, so b will have full power n. Now here we can see one thing. Suppose I take the second term t2. T2 is, second term is nc1 a to power n minus 1 b. The third term nc2 a to power n minus 2 b square. So we can see here one thing. When this is third term, this is nc2. Here 2 will come. When this is 2, b's power will be 2. Total power is n. So a's power will be remaining, n minus 2. So I can write a general formula for r plus 1 term. What it will be? N c. Okay. 1 less. When this is 3, this is 2. So r plus 1, then this will be r. Then here b's power will be r and a's power will be remaining, n minus r. So this is a formula for r plus 1 term, which is very useful in solving some of the problems. So let us do some of the expansions using this general formula. So here write first 4 terms. Write first 4 terms in the expansion of the first problem, 1 plus 3x to power 9. So, first coefficient will be 9C0. Now here your A is 1 and B is 3x. So 1 will have full power 1 to power 9. Then the next coefficient will be NC1. 1's power will be 8. And I will introduce 3x here. Then the next coefficient will be NC2. 9C2. 1's power will be 7. And 3x power will be 2, and see that the total power will be 9, and the fourth term will be 9C3, 1's power will be 6 and 3x to power 3 and so on. So now 9C0 is 1 and 1's any power is 1. So first term will be 1, then 9C1 is 9 into 3x, then 9C2 will be 36 into 3x the whole square, that is 9x square, then 9C3 will be 84 into 27, 3x the whole cube, that will be 3 cube into x cube, 27 x cube. And then simplify this, it will be 1 plus 27x. Then the next term will be 324 x square. And the next term 84 into 27, that is 2268 x cube. So these are the first 4 terms in the expansion, and as last time we have seen, when the power is 9 totally, there will be 10 terms. So we will be writing only the first 4 terms. Okay, take the second problem here. 5 minus x square to power 5, which I can write it as 5 plus negative x square to power 5. So the first coefficient will be 5C0. So 5 will have the full power 5 to power 5. Then the next coefficient is 5C1. 5's power 1 less, 5 to power 4, and introduce minus x square here. Then the next coefficient is 5C2. 5's power will be 3 minus x square to power 2. Then the next coefficient is 5C3. 5's power will be now 2 and minus x square power will be 3 and so on. So now we will simplify this. So 5C0 is 1, 5 to power 5, that is 3, 1, 2, 5. In the next term, 5C1 is 5 into 5 to power 4, and here the sign will be negative. So 5 into 5 to power 4, 5 to power 5, that is 3125 x square. Then the next term 5C2. So 5C2 will be 10 into 5 cube, that is 125, which becomes 1, 1250, and obviously the sign will be positive because negative square is positive. So 1250 x square the whole square, that is x to power 4, and then 5c3 into 5 square. If you do this on the calculator, it will come out to be 250. Negative cube is negative, x to power 6. So these are the terms in the expansion. So I'll give you some sums to do for practice. Write the first 4 terms. Write the first 4 terms in the expansion of the first one is 1 plus 5x to power 8. Second one, 2 minus 3x to power 7. Third one, 1 minus x upon 3 to power 5, and next one, 1 minus x upon 5 to power 9. So this is the general formula for binomial expansion, which you can use for higher powers. Which the steps are okay with you? Try these problems. Any doubts, please ask me. See you in the next class. Enjoy the day.